If tomatoes are fruit, does that make ketchup a smoothie? Why do we drive on parkways, but park on driveways? If you expect the unexpected, doesn't that make the unexpected expected? And seriously, how do we have pictures of the entire Milky Way galaxy from the outside if we are literally trapped inside it? Welcome to Midnight Questions. Today, we are answering, how did we take a picture of the Milky Way if we are inside it? Before we dive in, if you're new to the channel, make sure to subscribe so you don't miss our future late-night explorations. Consider our position. We exist on a single planet, orbiting a single star, deep within the borders of this galaxy. We are physically bound to this specific coordinate in space. Yet, a quick search online reveals hundreds of top-down views of the Milky Way. Viewing a perfect aerial perspective of a place you can never leave creates a genuine logic gap. It's the kind of thought that only seems to surface when the rest of the world is quiet. For almost any other object, the solution is to create distance. If you want a photo of a stadium, you simply walk backward until the entire building fits within the frame. This is NASA's Voyager 1 spacecraft, our most ambitious attempt to send a camera into deep space. Since 1977, this probe has traveled over 14 billion miles. To a human mind, that distance is nearly incomprehensible. But against the 100,000 light-year scale of the galaxy, those 14 billion miles disappear. Voyager's progress is a microscopic dot barely moving from its start. At its current speed, it would take 18,000 years to cross just 1 light-year. The math is final. Because no physical camera has ever left the galaxy, no lens has ever captured the images we see of our own spiral home. To understand how we see the galaxy, imagine you are standing on the 50-yard line of a massive enclosed football stadium. You are told to produce an image of what the stadium looks like from the outside, but you are never allowed to leave the field. You would start by documenting everything visible from your fixed position. You take photos of the north end zone, the south end zone, the sidelines, and the individual seats in the upper decks. This diagram shows the logic. By taking all those internal perspectives and stitching them together, you can calculate the external shape. You are building a 3D model of the building from the inside out. This inside-out stitching is the exact method astronomers use to bypass our physical limitations in the Milky Way. This wasn't a single project. Mapping our galaxy required a relay of observations spanning centuries. It began with ancient astronomers like Ptolemy, who first recorded the coordinates of the stars visible to the naked eye. During the Islamic Golden Age, scholars refined this by using advanced celestial geometry to calculate the precise paths and light phases of celestial bodies. In 1785, William Herschel manually tracked 600 specific locations in the sky to create this, the first rough outline of our galaxy's shape. By plotting these points, Herschel showed that our home wasn't a sphere, but a wide, irregular cluster of stars. Much later, Edwin Hubble proved that galaxies across universal space organize themselves into specific shapes, including flat, rotating spirals. When we look at this dense band of stars in our own night sky, we are seeing the edge of that spiral disk. It confirmed we are located in the outer suburbs of a flat spinning system. These historical efforts built the skeleton of our map. But for a long time, we couldn't see the full picture because of thick clouds of cosmic dust. This dust acts like a curtain, blocking visible light from the stars on the far side of the galaxy. To see through it, we developed space telescopes like Spitzer and WISE. This diagram illustrates how infrared light works. Unlike visible light, infrared waves pass through the dust clouds, allowing us to detect the heat and position of stars that were previously hidden. These tools allowed us to plot the trajectory and speed of millions of individual stars across the entire disk. We took those data points and used them to upgrade our historical sketches into a coordinate-based 3D model. So, to answer the mystery, the images you see online are not photographs. They are data-driven computer models, built from coordinate sets and light speed calculations. Instead of a camera lens, we used geometry to build a digital puzzle. We have successfully mapped a structure that we are physically incapable of observing from the outside. The result is a composite of centuries of individual observations, allowing us to visualize an impossible vantage point. We have a question for you. What is the weirdest question that has ever popped into your head in the middle of the night? Let us know in the comments below so we can answer it in a future video. If you enjoyed this, don't forget to like, share, subscribe, and hit the bell icon. See you next time.